So the second step,
Example, recent.
the second step, we have to
Drive.
separate the input and its label. Okay, in this case, the input is time. Yeah, and the label of the model is two-way. Okay. So this is the x. Okay, I will separate the column of time for x. Okay,
For
the
x.
input. Okay, and I
And
separate the label
yeah,
as the column y. Column of the weight is will be variable y for the label.
combine them.
Okay, so this step just separate between input and label. Okay, because we are in the topic of the supervised learning. Okay, supervised learning we need the input and we also need the label for response together. And okay, if you want to see what is x and y separated, you can print out x. Okay, if you print x, it means correcting of the time parameters, and print y, it show you only the weight. Okay, so right now x is correct time and y is correcting the weight. Okay, and next step. Okay, I just plotting the x and y. Okay, PLT is come from the matplotlib. Okay, the matplotlib is the library name for plot the graph. Yeah, and I try to plot the scatter with x and y. Yeah.
Okay, go
Okay,
on.
and when you plot the graph, it can show you about the
Yeah, you can go
x and y is refer to weight and time
Sure.
of data set like this. Yeah.
X, Y.
Okay, before going to the step of the training model, yeah, I have to prepare data a little bit because if you print out variable of x and y shape, okay, it's going to be look like it has a 165 data,
Just got
but it has no column. So we have to change the dimension style, like 165 rows and one column for x and y. Okay, because when you want to train the model with the linear regression model, they need the dimension as the two dimension. So right now, if you print out x and y variables that correctly one weight and height, you can see that x dot n ending or n dimension, x dot n dimension is come from, you want to check how many dimensions of your x and y. So if you print out, you can see that x and y, it has only one dimension. Okay, one dimension is look like it's like the list of number without the column. So if you want to change the one dimension of your data set to be two dimension, because as I told you that we should change the variable to be two dimension before training the model, because the function of the regression technique they need two dimension. So you can do like x dot value dot reshape with this one. Okay? If you follow this pattern of coding, it's gonna change you to be like 155 row and one column. Okay, so this step, try to do this. Okay, try to do like changing the dimension of your data set, one dimension to be two dimension. Okay, before training. Because the first time, I don't know, when I separate x and y finish, I input the x and y to the regression model, but it has some error. And try to fix that error, and it we know that we should change one dimension to two dimension before training. So that's why I have to explain this one for you. Yeah. Because it's like the format of regression model in this function. Yeah, we have to change from one dimension to two dimension before. Okay, and if you understand the process of the evaluation, okay, I would like to explain you in step 3. Okay. Are you okay? Are you okay about the step 2?
Yeah.
Yeah. Okay, step 3. It is the step of splitting data set. Yeah. Why we need split the data set? Do you know why we need split the data set to training and test set? Actually, it is the contents of the chapter 8. Okay, I will explain you a bit. Okay. So in this step, the step 3, when you want to do the kind of supervised learning, this is the different things between supervised and unsupervised learning, right? Because when you learn about the unsupervised learning, like the K-mean, DB scan, we don't need to separate or we don't need to split the data set, right? But in case of you doing the supervised learning, we need the process of splitting data between training set and test set. Okay. So let me explain you about the concept of the splitting data. Okay. Okay. Let's take a look at this one. It looks like you're trying to do some examination. Okay. For example, if I have like 100 questions, okay. For example, I have 100 questions, and okay, I give you like 100 questions for training. Like I give you 100 questions and take home. You can practice yourself with the 100 questions. Okay, and you can practice yourself. Sometimes the first time maybe you can get like 10 questions correct and 90 questions wrong, right? Okay, but you have time. You can find the answer. You can find the solution to get the correct one, like 100% correct. So when the day of the exam, I also give you the same question, like 100 questions that I gave you for practice yourself before. Okay, what happened? I think everyone can get the high score, right? Maybe 100 score. The average of the score may be 90% or 99%, because we use the same question as the homework or the practice question, right? But this solution is not fair, right? It has a bias, you know, because when you practice, you use this question already, and when the real exam, you also use the same question. Even the average of this class, the score is very high, like the accuracy is 99%, for example, but it is the bias. It is the bias solution. So that I explain you is like something like this. For example, you have 100 questions, okay? 100 questions for training the student, and maybe not only not all questions, but I just pick up some part of the question, testing the student, right? It is the bias. It is the bias solution, because the student already knows the whole question already. So the one way is that is better than the previous solution. we try to, for example, we have 100 questions at the same example, but okay, I give you only 70 example or 70 questions. You can take this question to practice yourself, okay? And okay, when the final exam, I keep another 30% of my question and test you, okay? Maybe the accuracy or the score of this class is not 99% as the previous one. For example, maybe the average of the score is might be 60 or 70%. But it is the like the fair test, right? It's not biased. Okay, it's reliable. So this is the meaning. That's why we have to split the test and training set. Okay, because we should train the model with the training data, and we keep another part of the data set for testing the model. Okay. So this is the concept why we have to split the data, okay, in terms of the supervised learning. Okay. So come back to our code, our program. When you want to splitting the data set you have, okay, so we have the function. We have the function for train and train split. Okay, you can import the scientific sklearn.model selection, and we import the function train underscore test underscore split. Okay, it is the function for split out the data. Okay, so this function, when you apply this function to your program, it will return 4 parameters. The first one is x train. The second one is x test. Yeah, and y train and y test. Okay. So right now x is referred to time, right? Our call, right? And y return your weight. Okay. But we try to split between train and trace with the x and y. Okay. So you can input x, y, that you want to split out x and y. And test size is mean how many percent you want to keep your data for training or for testing set. If you put 0.3, it means 30%. Okay? Because the maximum is 1. Okay? But normally, in terms of the data science, they prove that the suitable number for train and test can be like 70 and 30. 70% for training and 30% for testing. And some work or some application they might separate, like 80% and 20%. It depends on how many data you have. Okay. If, for example, if you have 1 million data set, like 1 million rows, maybe you can separate for 90%. If 90% it means 100,000 data, right, you have for training and 100,000 for test set, right? It's quite a lot for training the model. But okay, in many research, okay, they use 70, 30 or 80, 20 for separating between X and for separate train and test set. Okay. Random state. Actually, it depends on what number you want. But if you don't put this term of the variables when you run the program, this program will be select train and test randomly. So random set is mean they want to pick the position of random for you. So every time that you open the code and you run the program, it's going to random the same position. Okay. So if you don't put anything, it's going to random itself. It don't care about the position. You know, when you random the different position for training and test, maybe it might be affect to the accuracy. Yeah, like you select the different question for asking the model. If you random with the different question, maybe the answer is might be different. Okay, so if you running the program step by step, so you can see that X train and X test. If I put the dot shape after X train and we put dot shape, it means we can see that how many or what is the number of training or testing set. Okay, in this case the training set we have 115 data, okay, and 50 is X test, okay, in the input, and the same number of the Y train and Y test. Okay, so right now we can separate the test and train already. So we're going to move to the step 4. Okay, it gives the time for doing the regression. So from the scikit-learn, sklearn, linear model, we can import the linear regression. Okay. And then from the linear regression model, we can make the object variable as model like this. Okay. And then, so this variable, this model is referred to the linear regression model. So we can use the model dot fit. Dot fit is mean training. Okay, we are training the model. Okay, fit is mean the function for training the model. And then what we should put to the function. The first one we should put the input x underscore train, right? Because we need training and also we need the label, right? When we talk about the supervised learning, we should declare input and output, right? Input and label. Okay, the input is x train and output is y train. When you run it, maybe it takes a short time for training because you have not so many data sets, right? You have like 115 points for training, and your computer is very fast nowadays, so it takes a short time. But you know, the background of the algorithm is come from the mathematics that we learned last week. It's quite complicated, right? When you learn about the mathematics last week, but when you run the program, it takes a short time for calculation. Okay, so finish the training process. So when you train the regression model, you can get two main parameters between the theta 0 and theta 1. Okay, theta 0 is referred to the y-intersection, right? And theta 1 is referred to slope, right? Slope of the regression line. If you want to get the slope is can use the model for f underscore like this, and model.intercept underscore it refer to the theta 0. Okay. So if you run this one, you can get this number and this number for the theta 0 and theta 1. Okay. So you can write the equation as the below quoting. Okay. If you run this one, I try to print out like the linear model is W equal minus 143, because it comes from this parameter, it comes from the theta 0 plus theta 1, h is mean height or height. Okay. So this is the style for printing the variable. Okay. So from this equation, okay, you can use this equation for predict the height of user. So if you have this question, so you can predict your weight, right? You just input your height in the centimeter. Yeah. If your height, for example, you have like 172 centimeter, and you take this equation, you can get W, your weight in kilogram. Yeah. So this is the process of training model. But you know, when you training the model, it's not just training. You should know how we can evaluate the model. How like this model is good enough or not. You know, because we know only the input and we know only the variable, like the output, and we train with the input and output. We got the model. The model is here. The model is equation, right? The model is equation. But when you know the model, what is the performance of the model? We don't know. Right? We should test it. We should test the model. And